Okay, advanced math students, want to give you a little bit of a factoring review here today before we start in on using factoring and trig at the same time. Yes, that is where we're headed, and I'll give you a little teaser at the end of this video. But just so you know, I've made this document for you, tried to break it down the same way that we did when we studied it in algebra, so that the factoring pattern that we're going to use depends on however many terms it has to begin with. But there are a couple of questions, you guys, that you can ask yourself before you even start breaking it down by terms, and that's number one, is there a GCF, which remember stands for greatest common factor of all the terms there? Is there something I can break it down and make it a little smaller? And that is an important example to kind of think of in two ways. So let's say, for example, here, for our GCF example, let's say we had 36y x to the fifth minus 24y squared x squared and minus 8y squared. Okay, so when we're looking at this example, we need to consider, first off, are there numerical greatest common factors? And so out of 36, 24, and 8, hopefully we are all going to agree that a 4 can come out of all three of those numbers. So we'll pull a 4 out. But if we look at the variables as well, we're going to look at yx to the fifth, y squared, and another y squared x squared, excuse me, and then another y squared over here, and we're going to ask ourselves what is in common in all three of those terms, and that is simply just going to be a y to the 1. I can't go any higher than that because that's the smallest power that I have that all three of them actually do have together. So then it's a simple division, okay? Lot of factoring is all about division, remember. So we're just going to factor the 4y right out of this term, and 4 goes into 36 9 times. Y goes into y and doesn't leave anything, so we just need to keep this x to the fifth in play here. Then into the next term, 4y is going to divide into negative 24, negative 6 times. Y is going to divide into the y squared, leaving just a y to the first, and then the x squared has to tag along for the ride in that term. And then finally we're looking at negative 8y squared divided by 4y, and that's just going to be a minus 2y. Okay, so the question is, am I done? Am I done factoring when it looks like this? And I'm done if there are no other factoring patterns inside here, and also if there are no other common factors that I might be able to pull out. So it looks like I have three terms, or a trinomial here, and I don't think I have any other factoring patterns that I can pull out of all three terms. So or our greatest common factor that I can pull out of all three terms. So we're all set with the GCF example. Okay, continuing, our next type of example we want to go over is going to be over here in this left-hand column. If it has two terms, we're first going to check if it is a DOS, which is going to stand for difference of squares. Difference, remember, meaning subtraction, okay? So what we're going to do is look for the ones that have two terms and a minus sign in between. So something might look like this if we have a difference of squares. Might look like 4x squared minus 9. And you say, why is this a difference of squares? Well, we're going to look at two terms, this term here and this term here, and we're going to see that they are both perfect square terms. In other words, 4 is a perfect square, x squared is a perfect square, and 9 is a perfect square. So they're kind of all made up of perfect square pieces, if you will. The way that we know that this is going to factor, remember, is going to be, is going to be plus and minus, because that's what's going to get me to have two terms that cancel out when I do my FOIL. It'll be plus and minus, basically the square root of this front part and the square root of the back part. So the square root of 4 is 2, square root of x squared is x, so we just have 2x in the front piece of each of those binomials. And then on the back end, we're going to have a 3 and a 3. Okay, so that's just a difference of squares. And remember, if we were to FOIL it out, basically what would happen is that our outer and our inner there are going to cancel each other out. We'd have a positive 6x and a negative 6x, and that's why we see here that there is a 0x. There's no x term. That's why we're going to set it up this way. Okay, so that's a difference of squares if there's two terms. And just a quick reminder, if we had the exact same two terms for x squared plus 9 instead, this is what we call a sum of squares, or an SOS. I like to remember SOS means I'm in danger, okay? So sum of squares, because of the plus, we can't factor that. We can't pull it apart. We can't make the 0x thing happen like it did up here and have one plus and one minus, but still somehow get a positive 9 at the end. So if we get something like that, or even something more simple, just like m squared plus 16, okay? If it is a perfect square on the front and on the back, but we have this really bad plus in the middle, it is not factorable. So that's two terms. The next pattern we're going to look at is going to be if it has three terms in it, and that is, first off, if it's going to be a perfect square trinomial. So what we want to be aware of there is that if it has three terms, for instance, something like, oops, let's try that a little better there, give us some more room. If we had an example sort of like this, so ignore that 4x squared minus 9 right now. So if we had 64 g squared h squared plus 48 g h plus 9, okay, if we had that for our original, what we can think of is when we go back and look at our pattern here, the pattern is asking us, is b equal to 2 times the square root of a times c? So going back to our example here, is the middle term, that's the b, okay, is that going to be equal to twice the square root of this times the square root of this? So let's just do a couple quick little square roots here. Off to the side, the square root of that is going to be 8gh, and the square root of 9, as we know, is going to give me 3. So if I take 3 times 8gh and then I double it, hopefully you can see that's 24gh times 2. That absolutely is my middle term. So here's how this is all going to factor. If it is a perfect square trinomial, oops, there I go again. If it is a perfect square trinomial, we're going to have a binomial. The sign in the middle is going to translate to the sign in the middle of the binomial because it has to be a positive 48, so we need to make sure it's a plus in the middle. And then whatever I got for those square roots, that's going to go in the front, and that's going to go in the back. So this is 8gh plus 3, and then this is the kicker, okay? It's got to be all squared, because if I were to, again, FOIL and FOIL this out, we would get our first by getting a square of this front term. We would get our last by getting the square of that back term. And we would get an outer and an inner combination of those two terms multiplied, and then twice that, because it would happen for both the O and the I. So that's what we're looking at for a perfect square trinomial. Okay, getting to our next three-term pattern here, going back to, guys, I don't know why this is happening here. I'm going to try to get rid of this 4x squared minus 9 if I can. Maybe. There we go. Okay. So moving on to the next three-term pattern, it is going to be factorable trinomial. So let's zoom back out here. Factorable trinomial, and we'll come down underneath this time to an example that might start very simply, just x squared minus 13x plus 36. If we had an example like this, you can see the instructions here. We are going to say, and of course a is 1, okay, there's no coefficient there, so a is 1. So we're going to find c's factors, c being our constant, 36, find c's factors that add up to b, and then make sure your signs are right, and that's what the etc. means. So we're going to look for the factors of 36, and I just do a quick little factor chart here. The factors of 36 start as 1 and 36. Now I need a positive 36, but I need a negative sum. So they both need to be negative. But the sum of those is negative 37. That is not what I need. Okay, let's go to the next pair. Negative 2 and negative 18. Next is going to be that sum is negative 20. Well, we're getting closer, but that's not it. Okay, let's go to the next one. How about negative 3 and negative 12? Well, that's even closer, but nope, no dice. Finally, we're going to be at negative 4 and negative 9, and that is the sum that we need. So now we're going to start making our parentheses, remember? We know we're going to get x squared by x and x, and we got a minus 4 and a minus 9. Okay, so that's a factorable trinomial. Before we get to the next part, which is when a is not 1, let's skip over to our 4-term pattern really quickly, and that is factoring by grouping. Okay, we'll come back to the factorable trinomial here in a second, but if we had a factoring by grouping problem, meaning there were 4 terms to begin with, here's an example of something that might be factoring by grouping. We would have 7xy plus 42x plus y squared plus 6y. If we started with this 4-term list here, we know we're going to be doing factoring by grouping, or at least trying it. And what we're going to do, you guys, remember, is we are going to split these 2 terms right in half, okay? And we're going to look at, in the first 2 terms, is there anything in common we can pull out? And that is very true. We've got a 7x that we can pull out, and that is going to leave us with a y plus 6, okay? Same thing on the back end here with these back 2 terms, what can I pull out? And what I can pull out is the y, leaving a y plus 6. Well, wow, that's really awesome. That looks pretty familiar because the y plus 6 is now in both halves. So I'm going to pull out that underlined red piece of y plus 6, and I'm going to leave left over what I have in front of each of those common parentheses, which is 7x plus y. Okay, so that's factoring by grouping. Again, it's really important that sometimes when you're done with factoring by grouping, you may need to look for other 2-term or 3-term patterns. Like if this right here was still a difference of squares, let's say, you would want to break that down again. So things like that, just be aware of. Finally, you're going to go back to our 3-term pattern here. And our 3-term pattern of if a is greater than 1, meaning the the coefficient of the x squared term is going to be bigger than 1, we want to find a times c's factors. That's a really crucial step there that are going to add to your middle term and so on. So here's an example, something like 2n squared minus 5n minus 12. Okay, so what we need to do is we need to take a times c, a being 2, c being negative 12, and we're going to do our factoring factoring list of factors, but we're going to do the list of the factors of actually negative 24. Now be aware here with our factors this time, we still need to add to the middle term, but because we need a negative sum and a negative product, what we need to be aware of is that between these 2 numbers, remember the smaller numbers over here, the bigger numbers over here if we're making an organized list, the bigger number is going to be the one that needs to have the sign of the result in the middle. So in this case, that means that that's going to have a negative sign, okay? So we're going to start with negative 24, but it needs to be a positive 1, okay? That sum is negative 23. That's not what we need. We need negative 5. So let's keep going. If we use a 2, we need to use a negative 12 to get the negative 24 sum, and, excuse me, negative 24 product. The sum there is negative 10. Nope, not what we need yet. Let's keep going. If we use 3 and we use negative 8, I hope you can see that that is the pair of factors that we need. Now here, instead of just going straight to the parentheses like we did before when an a was just 1, what we have to do is we have to kind of do Splitsville here with this middle term. So we're going to take the trinomial and we're actually going to split it into the 4 terms, factoring by grouping idea that we just used. So 2n squared is going to stay as is, minus 12 is going to stay as is, but these 2 terms in the middle here of 3 and negative 8 are going to become the coefficients on the middle negative 5n. So it'll be positive 3n and negative 8n is what that negative 5n is going to split to. Now here's the magic. Watch what happens. We've got 4 terms now, so we're going to use a factoring by grouping approach. We're going to cut it in half. We're going to take out what's in common in the first 2 terms, which is just an n. That's going to leave you guys just 2n plus 3. Now if this is a factoring by grouping approach, we know that hopefully this second parenthesis is going to be the same. In order to get a positive 2n plus 3 in there, notice we need to make sure that we have a negative 4 out in front of that parenthesis. So again, just be aware as you are doing this, whatever this third term's sign is going to match that number pulled out of the back half there, okay? Finally, we're going to collect what's in common, which is the 2n plus 3, and we're going to leave it n minus 4. Okay, so I know that was a little lengthy. You may not need to know all of those pieces. I welcome you to revisit this if you need to, but hopefully that was a good overview, and hopefully you guys can get right to your factoring review. Oh, I promised you a teaser. Here's the teaser, okay? Here is the reason, you guys, that we are doing all of this work right now. What we want to do, oh, I can't get the thing to move. Hold on. Let's try this again. Oh, we've lost some space. All right, I'll go to the next slide. Okay, so here is the whole reason that we're doing all of this, okay? Because here's where we're headed. We're going to take a factoring approach to the following problem. Let's say we had 9 sine of theta squared, which actually we write sine squared theta, you're going to come to see. But let's say we have 9 sine of theta squared plus 6 sine of theta plus 1 equal to 0. Okay, if we have that situation, what we need to be able to see it as is 9x squared plus 6x plus 1 equals 0. And if you are able to see it as that factoring pattern and know how this factors with just x, then what we will do is we'll factor it, and then we will use our applications, then apply the trig side of it. But we've got to know how to factor it to begin with. Okay, so again, that's what's coming. I'm not going to do that tonight or today in class, but that's where we're headed. Okay, all right, get to work.